Okay, so in this video I'm going to have a look at what's called implicit differentiation. It's just a method of differentiation when a function is implied. Normally our functions will look something like this: y is equal to 3x plus 5 or something like that. So y is written in terms of x. So to differentiate that, dy dx, we would just simply get 3 here. So that's fairly straightforward. But if we have a function that looks like this: x squared plus y squared is equal to 25, we don't have y in terms of x, so a function is implied here, if you like. Now this is simply the equation of a circle. So it looks something like this, and you've got center 0, 0 here. And you have a radius here of 5, the square root of 25. Now let's say this point here is 3, 4. If we want to find the slope of our tangent here at the point 3, 4, so we have a straight line here, or roughly a straight line anyway, should be a straight line, at 3, 4. If we want to find the slope of this line, we need to differentiate this function and then put 3 into our differentiated function. That will give us the slope of this line here. That's the way we've normally been doing it, but we don't have y in terms of x here, so let's just rearrange it and see what we get. We'll get y squared is equal to 25 minus x squared, so y is equal to the square root of 25 minus x squared. It's actually plus or minus here. So since we're talking about the top half of this circle here, this part here, we're just going to talk about the plus version of this square root. So it's just going to be 25 minus x squared to the power of a half. That's y. Now to differentiate this, we need to use the chain rule because we have a function of a function. So dy dx is just going to be equal to, bring the half down here first, we get a half, times 25 minus x squared to the power of minus a half. Subtract 1 from a half, you get minus a half. Then multiply that by what you get when you differentiate what's inside the bracket, and that's just minus 2x. So to tidy that up, we end up with minus 2x all over 2 times the square root of 25 minus x squared. 25 minus x squared to the power of minus a half is 1 over 25 minus x squared to the power of plus a half, which is just square root here, square root of 25 minus x squared. Now that's just simply minus x over the square root of 25 minus x squared. That minus 2 will divide into that plus 2 minus 1 times here. So this is what we end up with. Now, if we put our x value in, our x value here was 3. So put 3 in here, our slope will just simply be minus 3 over, you put 3 in here, you get 3 squared, which is 9, from 25 is 16, the square root of 16 is 4. So our slope is minus 3 over 4. Now we haven't done implicit differentiation at this stage, but if we were to take our original function, x squared minus y squared equals 25, x squared minus, x squared plus y squared even, so x squared plus y squared equals 25. I'm going to differentiate this implicitly. So, excuse me, so what I'm going to do is differentiate each term as it stands. I'm not going to do any rearranging. So differentiate x squared with respect to x. Differentiate y squared with respect to x, and differentiate 25 with respect to x. That's what we're going to do. So if we differentiate x squared with respect to x, that's just simply 2x. Now, when we differentiate y squared, you've got to remember that y squared, y itself is a function, so y squared is a function of a function. So what we're doing is squaring our function y. So what we would normally do then is the chain rule. So we need to differentiate this as a whole first. If you like, take that 2, bring it down here, subtract 1 from our power. That gives us 2y to the power of 1. We then need to differentiate the y itself. Now if you differentiate y with respect to x, you get dy dx. Just simply write it down as dy dx. Now differentiate 25 with respect to x, you get 0. So what we want is dy dx here. So I'm going to isolate the dy dx. So take that 2x and bring it over here, or subtract 2x from both sides. You get 2y dy dx is equal to minus 2x. Divide by this 2y is multiplied by the dy dx. So dy dx is just simply minus 2x over 2y, and that's just simply minus x over y. Now that's what we got originally here. If you look at our original differentiation up here, when we did it without doing implicit differentiation, we got minus x over this here. This here is just y, remember. Look, y is equal to plus root 25 minus x squared. So this is y, minus x over y. And that's what we got here, minus x over y. So again, if we put our 3 over 4, or our 3, 4 rather, into this here, 3 was x, 4 was y, we still get a slope. We get our slope here of minus 3 over 4, which is what we got originally. Okay, so that's how you do implicit differentiation. So let's have a look at a few other examples. So let's have a look at a more complicated example. Let's have a look at, let's say, y to the power of 4 plus 4y minus 3x cubed sine y, all of that equal to 2x plus 1. Excuse me. Now here we have a y to the power of 4, here we have a 4y, here we have a sine y. Now I don't know, I haven't tried rearranging this, but I think it's very, very difficult, or if not impossible, to isolate y, to write y in terms of x here. So I'm not even going to try it, but what I'm going to do is differentiate this implicitly. So I'm going to differentiate y to the power of 4. That will give me 4y cubed. Bring the 4 down, subtract 1 from the 4, and you get 3. Now we must differentiate the y itself as well, so we get dy dx. Here we've got 4 times y, so differentiate y with respect to x. We will get dy dx here as well. Minus, now differentiate this here. This here is a product, remember. We have 3x cubed multiplied by sine of y. So we have a product of 3x cubed. We have 3x cubed multiplied by sine y, a function multiplied by a function. So I'm going to call this u, I'm going to call this v, and what I'm going to do is u dv dx plus v du dx. Okay, so let's do that. Now u is 3x cubed. I'm going to multiply that by dv dx. If you differentiate sine y, you're going to get cos y. Now you must differentiate the y itself because it's not sine x. If it was just simply sine x, you would just write down cos x. But because it's sine y, you must differentiate the y itself. So that's just dy dx. So it's cos of y multiplied by dy dx. Now that's the first part done. Now it's plus v, which is sine y, and we must multiply that by du dx. Du dx is 9x squared. 9x squared. So that's it. And all of that is just going to be equal to what we get when we differentiate the right hand side here, which is just 2. Differentiate 2x, you get 2. Differentiate 1, you get 0. Now let's just simplify that a little bit further. Let's see, we've got 4y cubed dy dx plus 4 dy dx minus 3x cubed dy dx cos y plus 9x squared sine y. And that's all equal to 2, and in fact it's not plus here. It's going to be, because you have a minus here, this is going to become minus, so you got to be a little bit careful here. Very easy get make little mistakes with signs here. So we have let's see, we have a dy dx here, a dy dx here, and a dy dx here. I'm going to factorize these three, and I'm going to take this term here without the dy dx, and I'm going to bring it over to the other side. I'm going to add a 9x squared sine y to this side and to the other side. So factorizing here, we get dy dx, and if we take it out of here, we get 4y cubed. So here we end up with plus 4. Here we end up with minus 3x cubed cos y. I think that's it. And over here we end up with 2 plus 9x squared sine y. 9x squared sine y plus 2. Okay, so now we had 3 dy dx's here on this side. We've now only got 1. It's multiplied by all of this, so all I got to do is divide both sides by all of this here. So we end up with dy dx is equal to 2 plus 9x squared sine y, all divided by 4y cubed plus 4 minus 3x cubed cos y. And that's it. When we differentiated that original function, this is what we got here. As I said, it would have been virtually impossible to isolate y, or to write y in terms of x originally and then differentiate. So it's a lot easier just to differentiate implicitly. Okay, so let's have a look at another example. So now I'm going to take another circle. Our circle this time is going to be in a different format. We're not going to have 0, 0 as our center. We're going to have let's say 3 minus 4 as our center. So I'm going to write it as x minus 3 to be squared plus y plus 4 to be squared is equal to 25. Now this again is a circle. It's a circle that looks, I think, something like that. Our center is going to be here. It doesn't really look too good. Let's see. Just redraw that. Maybe I'll draw the circle first. So we'll have a circle first here. Our center is going to be 3 minus 4. 3 minus 4 here. So we go out 3 and down 4. So our x and y are going to go out 3, go down 4. So maybe, so I don't know, something like this. Okay, so go out 3, go down 4 here. So our center is down here. Okay, so in this particular case, we're going to differentiate again implicitly. So you got to differentiate this term here in terms of x. So again, we need to use the chain rule. It's a function of a function. So bring the 2 down here. We get 2 times x minus 3 to the power of 1. Now we must differentiate what's in the bracket here, and that just gives us 1. Plus, differentiate again, bring the 2 down. And we have y plus 4 here. Subtract 1 from the power. Differentiate what's inside the bracket here. Just the y here, we get dy dx. When we differentiate 4, we get 0. On the right hand side, differentiate 25, we get 0. Let's just simplify that. We end up with 2x minus 6. 2x minus 6. And over here, I'm not going to multiply this out yet because it's all multiplied by the dy dx. Let's see, 2 times y plus 4 dy dx. And that's all equal to 0. So let's just bring these over to the other side. Or subtract 2x, add 6 to both sides. So we end up with 2 times y plus 4 dy dx is equal to, bring the 6 over, that becomes 6. Bring the 2x over, that becomes minus 2x. And that's it. So we end up with, divide both sides by this bit here. We end up with dy dx is equal to 6 minus 2x all over 2 times y plus 4. Now, I think this will simplify further. Let's just have a look. Dy dx is equal to, I can factorize the top anyway. I can take 2 out here and I end up with 3 minus x. That's over 2 times y plus 4. 2 will divide into 2 and I end up with 3 minus x over y plus 4. So what I get when I differentiate that particular circle equation is 3 minus x over y plus 4. Now I had a point up here, what was it, 3, 4. 3 minus 4 as my point, my center. If I took any point on this circle, anywhere around here, let's say, I don't know, 5, I don't even know if it's on this circle, but let's say 5 minus 2 was on this circle. It may or may not be now. I'm just making this up. So 5 minus 2. If we had this point 5 minus 2 on this circle, all you've got to do, if you want to find the tangent at that particular point, you just put 5 in here, 2 in here, and that will give you the slope of that tangent at that particular point. Okay, so that's another example. Let's have a look at one more. Again, a circle. We'll take a circle in a different format again. X squared plus y squared minus 4x plus 5y minus 8 equal to 0. So let's differentiate this implicitly again. Again, you've got a y squared and you've got a 5y here. It may not be possible to isolate y here to get right y in terms of x. So you would need to differentiate each term individually. So let's do that in terms of x. So differentiate x squared in terms of x, you get 2x. Differentiate y squared in terms of x. So y is a function and you're squaring that function. So you've got to do the chain rule. So it's going to be 2y. First of all, bring the 2 down. Subtract 1. Then differentiate the y itself. So you're going to get dy dx. Differentiate minus 4x, that will just give you minus 4. Differentiate plus 5y, now again in terms of x that's just going to be 5 times dy dx. Differentiate 8, you get 0. Differentiate 0, you'll get 0. Okay, so let's look at this. We've got a dy dx here and a dy dx here. So I'm going to have to factorize these two to isolate the dy dx, and I'm going to take this 2x and the minus 4 and bring them over to the other sides, or subtract 2x, add 4 to both sides. So I end up with dy dx 2y plus 5, and on the other side I'm going to end up with 4 minus 2x when I bring these two over. Divide now, so you've got dy dx is equal to 4 minus 2x all over 2y plus 5. And that's it. I can't simplify any further really. So when I differentiate this function here implicitly, this is what I get, 4 minus 2x over 2y plus 5. Again, if you try to isolate the y, if you try to write y in terms of x, if it's possible at all, it's going to be very difficult. It's going to take you a lot longer. First of all, to isolate the y, and then to differentiate it. This is a lot shorter, a lot simpler. So that's it for implicit differentiation.